Hello, my name is Ryan Stutzman, and today I will be presenting my project proposal for the sonification of digital image pixel data. So an introduction. The relationships between color and pitches have been well documented through work in synesthesia and color imagery portrayed in music. Colors are described as being warm, cool, or eliciting a stylistic response. These associations serve a purpose in artistic composition and human perception. This research seeks to bridge the association of color and sound through the scientific medium of sonification. By collecting red, green, and blue light balances of individual color pixels, accurate representations of color-sound relationships can be found. This research intends to find the underpinning relationships between color and pitch through testing pixel samples and the resultant sound structure. Purpose of the project. The purpose of this project is to find the underpinned relationship between color and pitch. Through the creation of a sonification tool, the end user will be able to hear authentic representations of the color spectrum. By dividing colors into individual red, green, and blue, or RGB light, will serve as an authentic sonic representation of the color spectrum. The secondary purpose of this project is to create a new means for music creation. The end user will be able to utilize color spectrum and the resultant sounds of the sonification for music composition and performance. The resulting sonification of RGB light will create varying monophonic to polyphonic representations of individual colors. This research may provide a new approach to multimedia performance. This research may provide an aid to blind users who wish to aurally experience color. The conceptual design. The conceptual design of this project will follow an iterative design model. The iterative design model is a cyclical process. The design model will begin with prototyping, followed by testing, analysis, and refinement of the design. The project prototype will be designed and created. Several test users will test the design. Problems with the design will be noted and diagnosed. The design will be refined and again released to the test users for feedback and design refinement until a final design prototype is reached. The project will be developed in the Max MSP Jitter 7 environment and tested through the cyclical trials of the parts and whole of a working prototype. The success of this project will be determined and measured in 3 parts. The first part will be the creation of a functioning proof of concept design. The second measure will be in the accurate sonification of RGB data and cataloging of waveform data. The third measure will be in the creation and/or performance of a sonified digital image. Project content. This research proposes the creation of a sonification tool that can synthesize individual pixel RGB data and apply it to the audible pitch spectrum. This research will combine current work in the disciplines of musical sonification, direct sonification through the proposed proof of concept design and the results of the prototype. The idea developed out of viewing images of nature and seeing visual patterns relating to music. Specifically, as notated on the screen, there's a satellite image taken of the Martian black sand dunes that to me resembles an old music box cylinder. Curiosity concerning what the picture might sound like fostered the development of this project. Sequence and layout. The first phase of this project is to collect past and current research in the field of sonification. This research will include how sonification has been used, effective uses of sonification in science and music, and the aesthetics of sonification. The second phase of this project is the creation of the sonification tool and a proof of concept design. The design will be tested using an iterative design model. The environment will be built within Max MSP Jitter 7 software and be comprised of 4 components. The first component of the patch will be the image import. The second component of the patch will be the image pixel data array. This will collect and arrange the pixels chronologically. The third component is the identification of RGB balances within each pixel. And the fourth component is the RGB balance playback. Each color will be represented as a waveform and played simultaneously. These components will all be combined and then presented in the presentation mode feature of the MaxMSP Jitter environment. The presentation mode will synthesize the components into a single screen containing the necessary user interactions for the patch in a linear format. Instructions for guiding the user through the process will be labeled chronologically on screen. The final prototype will be available for user download as a max runtime object. The third phase of this project will comb through the sonified RGB data in digital images to find sample colors that mirror music theory concepts and Western tonality. Through the use of the RGB data and a musical tuner, each pixel color will be identified. The interaction of the three RGB waveforms will produce an infinite number of combinations. This research will aim to find the resultant sonifications that mirror Western tonality, a perfect interval, a major chord, a minor chord, and a seventh chord. The reason Western tonality was chosen is based on my familiarity with Western theory and for simplified compositional purposes. Once the colors are discovered that mirror Western tonality, the colors may be combined to create performable music works, creating accurate representations of color. The fourth phase of this research focuses on the applications of the research. The goal of this research is to create a framework that will illuminate the relationship between the color and sound spectrums and apply the data to both create a new medium for music creation and a tool to hear RGB light interactions. Pictured here is a basic layout of the project. Left to right is the pixel array. Then next to that is the rendered image and audio playback. And then to the far right is the image import. Evaluation of the project. Evaluation for the project will be presented in the form of an observer questionnaire. A rubric will be created for observers to rate the different aspects of the sonification tool and performance viability on a measured scale. Evaluation for the program usability will be presented in the form of a questionnaire for test users. A rubric will be created that addresses the different aspects of the program. Aspects to be rated will include but are not exclusive to the layout, ease of use, practicality, performance practice, and any additional comments about the uses or usability of the prototype. Here's the project timeline. It is presented in a 16-week format, beginning with the basic design leading all the way to the final steps of a performance using the tool. Noted here are the expenses for this project to go beyond the initial prototype. The expenses for this project are minimal. The physical development kit for digital image sonification will include a 32 by 32 LED display, programmable Arduino platform, Molex pin connectors, and a field recorder for recording color sonifications, data, and testing feedback. A pre-existing version of MaxMSP Jitter software will be used to code the program. And here's my bibliography. Thank you.